So in question 3, we are looking at some composite functions, but the functions that we are given involve exponential and logs, natural log, ln. So before I go through this question, I'm going to do a quick revision of log laws. From page 337 of your Pure Book 1, these are your 3 main laws that you need to know. They are not given in the formula booklet, okay? And when I'm marking exam scripts on these, I see large numbers of mistakes on these written down incorrectly. Basically, you need to learn them and be aware of the following types of errors. So first bunch of errors and incorrect versions of the multiplication log law. Here we've got log x plus log y equals log xy. Sometimes I see this log of x plus y is log x plus log y, where it's almost as if the log has been multiplied out over the bracket, log times x and the log times y. Completely wrong, don't do that. Next one, where we've got log x plus log y equals log x log y. There's some really quick checks that you can do for this. Just in your calculator, write down your rule as you remember it and then check it. So here I would write log 3 plus log 5 and get my calculator answer. I get 2.708. And then check log 15 is 2.708. These are the same. That sort of confirms that rule that I've learned there. If I tried it here, I'd be looking at log 3 plus log 5. And then I'd be in my calculator doing log 3 times log 5, and I would find that they are completely different answers, not correct. Okay. And again, this one is another error. To check, if you wrote that down to check it, you could write in log of 8, 3 plus 5. Check, does that equal log of 15? No, it doesn't. So you've got your basic law wrong. Unless you get these laws correct in the first place, you will pick up no marks on these types of questions. Similarly, mistakes with this division law. Often see log of x minus y inside the bracket to be the division, log of x divided by y, or equally log of x minus y being log x over log y, or even log x minus log y being log x over log y, all of which are incorrect. But you can check that with a really quick log on your calculator. Log of 2, which is 5 minus 3, well, is that the same as log of 5 divided by 3? And you'll find it's not. All incorrect, these ones. Okay. Last one is fairly straightforward, easily remembered. Okay, so the next thing that really helps us to understand the nature of logs is the log graph. So sketch it, learn it, and we'll have a look at some key features. So we sketch it first of all by remembering that it is the inverse function of the exponential function, y equals e to the x. My sketch of y equals e to the x is here. It goes through the point 0, 1 there. And so if it's a reflection in the line y equals x, then that goes through the point 1, 0 there. Okay, which is great because actually just knowing that tells me that ln of 1 must be 0. Okay, looking at the shape of the graph here, ln is not defined. No logs are defined for x greater than 0. So ln, where x is negative, not defined. So sometimes we'll end up rejecting a solution for x because it comes up with a negative term inside that ln bracket. The next thing that we can see from this sketch is that if x is between 0 and 1, then that part of my ln graph is below the axis, it's negative. So I know that ln of any number between 0 and 1 is negative. And when you solve inequalities with learn, obviously it's important to know if you're multiplying or dividing by a negative. If and if your learn is, like, say, learn of a half, then you know that that's going to be a negative value, and so on. Okay, so back to the question. First of all, find fg of x and state its range. So fg of x means I'm doing f to ln of x plus 1. So I'm doing e to the 2 ln of x plus 1 plus 4. Key thing here is I'm going to manipulate this first part of the expression there. The 2 can go up and become the power. So I've got e to the ln of x plus 1 squared plus 4 at the end. So another thing that we need from our log laws is that e and ln are inverse functions. So if I've taken the ln of x plus 1 squared and then I raise it to the power e, they basically cancel each other out, like squaring and square rooting. So that brings me back to x plus 1 squared plus 4. Okay, so this is fg of x in a simplified form. I need to state its range. Now, we're told here the domain here is x is greater than -1. And so if we have a look here, well, regardless of whatever my value of x is, my squared part is always going to be greater than or equal to 0. Here it would equal 0 if x were equal to -1, but we're told that in our restricted domain it's not equal to -1. So this means that this squared part will always have some value. So therefore my range is fg of x is going to be greater than 4. Note that if I didn't have this restriction on my domain and x could be any real value, any real number, then it would be possible for x to equal -1 and fg of x could equal 4. So that would be a greater than or equal to 4 there. But because of that restricted domain greater than -1, that's my range is restricted as well. On to part B, and we're solving fg of x equals 85. So this is our equation. Now, quite a few of you ended up multiplying out this squared bracket, bringing the 85 over to one side and getting a 3-term equation, 3-term quadratic, and solving that. When you've got it in this form, by far and away the most efficient efficient method is to just crack on and solve it from here. So if I subtract 4 from both sides, I get x plus 1 squared equals 81. I square root, and I'm going to have x plus 1 equals plus or minus 9, and then subtract 1 from that, and I'll have x equals 8 or x equals -10. That's what I would get for solving that. Look back at the context of this question. We are told here that x is greater than -1, so I can reject that solution. My solution is that x equals 8, and I must make it clear that that's my solution. The reason that x cannot equal -10 is actually back up here. If I put x was -10 in here, I would end up with ln of -9, and we know from the shape of our ln graph does that, -9 down there, ln is not defined. Okay, so that's why that is not a solution to fg of x, because we cannot find g of x for a negative. Okay.